All right, welcome to the 4-2 notes. Last time we looked at quadratic functions. We're going to look at them again today, but we're going to look at them strictly from standard form. This is probably the form that some of you are more familiar with because this is the form that we used in Algebra 1. So what we're going to do is first let's discuss what standard form exactly is. Standard form is in like this, right here. Okay, f of x equals ax squared plus bx plus c. Okay, that is standard form for a quadratic function. All right. For any quadratic function, the values of a, b, and c provide key information. So similar to vertex form, where we could look at that and like get some information from it, we can do standard form and we can get some information from that also. So let's take a look at the features of it. And your book shows you how to do this in a calculator, and I can show you how to do this also in class. It'll be easier to do on the calculator, so we'll look at that. But from a graph, and some of you guys have asked about this recently, from a graph, we can find the vertex, the axis of symmetry, whether it has a max or min, and the range, all from this form right here. Okay, I'm going to show you how to do that. Sorry about that. All right, so just from looking at it, we can find on our calculator that the minimum is down here at -10, so the range has to be y is greater than -10. We can find the vertex on our calculator from -2 and -10, so we have that. We can look at it as a table and notice that the axis of symmetry is x equals -2 because that's when the numbers sort of reverse order. And then we can also find that -10 is the minimum value. Okay, so lots of information that we can get just from a picture. All right, so if you had to, what are the vertex, axis of symmetry, max or min, and range of y equals -3x squared minus 4x plus 6? So again, I'm going to put this in the calculator. I'm going to go ahead and do it in the Casio. If you have a TI, I'll address that in class. The Casio does it easier, and so we're going to do it a little bit faster that way. So -3x squared minus 4x plus 6, and I'm going to graph that, and I get this. Now, I can't see everything I want to see, so I'm going to go to my view window, and I'm going to change it to standard, so it's a 10 by 10. Now I can see it a little bit better. The Casio has a really nice feature right here at F5 called G-Solver. It solves for things on a graph. So if we wanted to know the max, and I know this has a max because it's facing down. If I were to hit F3 for min, it would say not found because it doesn't have one. If I hit F2 for max, I get the max is at 7 1/3. Okay. The axis of symmetry is right here also. The vertex is -2/3 and then 7 1/3. So the axis of symmetry is at x equals -2/3. What else did they want? And the range is y is less than or equal to 7 1/3. All right, so there we go. Vertex, axis of symmetry, max or min, and range. All that just from the picture, and it's very easy for you right there in the Casio. We can also find information about the quadratic function from the coefficients of a, b, and c, and from the constant term c. So let's look at what those can tell us. And this is, the book tries to give you some hints here. Take note. So some things to know. One, we know it's a parabola. Okay, so we should be pretty comfortable with that. If a is greater than 0, it opens up. If it's a is less than 0, it opens down. We should be pretty comfortable with that. The axis of symmetry is the line right here. It's at x equals -b over 2a. Okay, so the opposite of b over 2 times a is the axis of symmetry. All right. The x-coordinate of the vertex is also -b over 2a. The y-coordinate of the vertex the y-coordinate, to find that, and this looks complicated. Once we have the x value, all we do is we plug that in and we solve and we get y. So it's y equals f of -b over 2a. So we can plug this value here in for the x, solve for y, and that's how we get the y value. And then the y-intercept is very simply the c term. Okay, and then here that is here's that same information as a picture. So here's how it works, or here's why it works. So some of you might get lost on this here's why it works part, and if you do, that's fine. Remind me and we'll walk through this in class. So this is the vertex form where we've started. Okay, if we factor this out, or if we FOIL right here, we end up with x squared minus 2hx plus h squared. Okay, then I'm going to distribute the a to each one of these terms. Okay, in here now I have ax squared plus negative 2ahx plus ah squared plus k. So all we did is we distributed this out and multiplied it and all that. If we compare that to the standard form, a is a in both of them, okay, so there's no problem there. B is negative 2h, negative 2ah, all right? Negative b over 2a is equal to h. And then since h is that, the axis of symmetry is that, and the vertex is simply h and then k. If you need more follow-up on this, it's just basically taking it from vertex form to where we started and showing you why the same things work in standard form. So how would we use that? All right, so, well, first, what is the graph of this? So we can identify A, B, and C. A is 1, B is 2, C is 3. So we know the axis of symmetry is the opposite of B over 2A. So the opposite of B is negative 2, and then 2 times A is 1, so 2 times 1 is 2. So negative 2 over 2 is negative 1. So we sketch this line in right here, so no problem. Then we also know that's the x-coordinate of the vertex, so we need to know the y-coordinate. We just simply plug this negative 1 in, okay, and we solve for y, and we get 2, so there's that, okay. Since C is 3, that's the y-intercept, there's that point, and because I know the axis of symmetry, I can go on to the other side, put that point, and then it opens upward because a is greater than 0, so I can draw my graph. Really simple stuff. Go ahead and pause the video right here. See if you can't get me a sketch, a drawing, a graph of that function right there. Pause the video now. All right, so the first thing, I've moved this on a different page so we can see everything on a grander scale here, but let's take a look. We have, I've identified A, B, and C, so I have those, and I'm reminding myself of this right here, that x equals negative b over 2a. So let's find x first. So I have x equals, the opposite of b is negative 2, over 2 times a. Well, a is negative 2, so 2 times that is negative 2, which is negative 4. So x equals 1/2, okay? From there, so now we know that the axis of symmetry is at positive 1/2. So I'm going to draw that in. That is here, okay? All right, so we have that. Now, let's plug 1/2 in for x and find y, okay? So let's do that. So we say y equals negative 2 times 1/2 squared plus 2 times 1/2 minus 5. 1/2 squared is 1/4, and negative 2 times 1/4 is negative 1/2, plus 1 minus 5. And this is 1/2, and that becomes negative 4/2, okay, negative 4/2. So now I know that the vertex, so y equals negative 4 and a half. Did I say 4.5 or 4/2? Sorry, a whole little conversation there with myself. Negative 4.5, okay? So now I'm going to go down to negative 4.5, and I put a point, okay? So that's my first point. Now, the vertex, or sorry, the y-intercept is right here at negative 5. So I can go in, and I can put a point right here. Because of symmetry, I can put a point right there. I know that the a is negative, so it opens down. So my parabola is right there, okay? Feel free to make note, and we'll go over that in class as much as you want. But we can use each piece to figure out something else and then get our picture from standard form doing that. Let's take a look at problem 3. Problem 3, so converting standard form to vertex form. So how do we do that? Well, what we're going to do is, again, we're going to identify A and B. We're going to find the x-coordinate of the vertex because that is the h. We're going to use that, we're going to substitute in to find the y-coordinate of the vertex because that's the k. The a value stays the same, and then we substitute back in. So if we take a look here, and this is just algebra, okay? So follow the steps. I'll leave this up so we can see, and we can do this one together. If we follow the steps, we have, and again, the form that we're looking for, remember, the form that we're looking for is y minus a times, or y equals, x minus h squared plus k. So we need the vertex, really, is the big thing we need. Okay, so let's find the vertex. So x equals negative b over 2a. So the b value in the one they gave us was 4. And 2 times a, well, that's negative 1, so that's negative 2. So the x equals negative 2. All right, so we have that. Sorry, and I just misspoke. This was the opposite of b, so this was negative 4. So, whoopsie days. Sorry about that, guys. That's positive 2. See, everybody makes mistakes. So positive 2. Okay, so the x is a positive 2. So already I can write down a couple things. Y equals, the a is the same, so that's negative. So I know that's there, and it's positive 2, so I know that that's x minus 2 squared. We're just looking for k now. To find k, I'm going to take this 2, and I'm going to plug this back in, okay, just like what they did up here. Y equals, okay, and I go back to the original one, negative, and then 2 squared plus 4 times 2 minus 5, okay? And we simplify this, and I get y equals negative 4 plus 8 minus 5, and y equals negative 1. So back to my answer. K value is minus 1, and that's it. So now I've transformed standard form to vertex form. Okay? And really the big thing that you have to know is this x equals negative b over 2a. That gives you the line of symmetry, or the x value, the x point of the vertex, all sorts of stuff. Interpreting a quadratic graph, this looks a lot harder than it is. Step one is, we have this function right here, and we want to know how long is the section of the arch above the bridge and all this stuff. Really what we're going to do is we're going to find the vertex of the arch, so we do that. And then we find the height of the arch above its supports, so that's 360. Okay, so now we have the y coordinate of the vertex is the height of the arch above its supports, so that's there. And then we find the arch of the height of the arch above the river. Okay, the arch is about 360 feet plus 516 feet, which is 876. And if you look at it, this is all labeled right here. Okay, so that's 516, the height of the arch. That was the 360. Okay, and then it says the length of the bridge above the arch. The x-coordinate of the vertex is half the length of the bridge above the arch. The length of that particular part of the bridge is 850 plus 850, so it's 1,700 feet long from beginning to end. Okay, this sounds complicated. I promise it's not. Okay, we just have to work these problems a little bit at a time. So now we have a bridge in China. It's the oldest known arch bridge, dating back to 605. Okay, you can model the support arch with the function f of x equals, blah, 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 all this, where x and y are measured in feet. How high is the arch above its supports? Okay, how high is the arch above its supports? So we just want to know height of the arch. Okay, height of the arch. And then why does the model in part A not have a constant term? Why does the model in part A not have a constant term? Okay, that part might be easier to understand. If it doesn't have a constant term, if there is no c, that means the y-intercept is at 0. Okay, so that part's a little bit easier. The y-intercept here is 0. Okay, if they didn't list it, it's because it's 0. Now we go to A. All right, so let's take a look at A. What we need is the height of the arch. Okay, so we want to know the maximum value. So we want to know the y. We want to know the vertex, okay, and then we want the y value there. So go ahead and pause the video here. See if you can do same steps that happened here, okay, so the opposite of b over 2a to get x, and about. It doesn't have to be perfect. And then substitute that in and find y and see if you get the same thing I get. Go ahead and pause the video here. All right, so through all that calculation, I got my x to be about 61 feet and my y to be about 4 feet. If you didn't get that, try it again. You might have made an order of operations error. If you still don't get it, go ahead and make note of that, and I'll go over exactly how I got that on the calculator in class. Hopefully this made some sense. This is going to take some practice, guys. Please make sure you watch the video. Obviously, you watch the video. Please tell somebody else to watch the video. Pay it forward. All right, see you next time. Bye.